Now the excipients used in parental dosage forms. Now what are the excipients used in parental dosage form? What are the antioxidants, chain terminators, and chelating agents. These three, these three we can use in parental dosage form. All these three we can use in parental dosage form. What is the oxidation? What is the oxidation? First one. What is the oxidation? How it is happening? Oxidation is happened due to the presence of oxygen only. Due to the presence of oxygen. Now the topic is oxidation. In the oxidation, what will be happening? First, oxidation, nothing but it is occurred by due to the presence of oxygen. Due to the presence of oxygen. So what is the structure of oxygen? See, oxygen O2, one oxygen, one oxygen. Each oxygen is surrounded by how many electrons? Each oxygen is surrounded by how many electrons? 1, 2, 3, 4, 5, 6. Each oxygen is surrounded by 7 electrons, not 6, 7 electrons. These 2 electrons are shared by these two. These 2 electrons are shared by these 2 oxygen. Hence 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 7 electrons. Each oxygen is surrounded by 7 electrons. So, in order to make stable octet configuration is needed. In order to make stable octet configuration means 8 electrons should be present around each oxygen. 8 electrons should be present around each oxygen. So, only 7 electrons are there. So, 1 electron less. Hence, each oxygen is surrounded by 7 electrons. Hence, these are electron deficient. This oxygen is electron deficient. What is electron deficient? Means it is having 1 electron less. In order to meet octet configuration, each oxygen should need 8 electrons. But it is having 7 electrons. That's why it is electron deficient, loss of electron. Hence, acts as an electron deficient. So, whenever it is electron deficient, it need to take electron from the drug molecule. It take an electron from the susceptible functional group present in the drug molecule. It will take 1 electron from the susceptible functional group present in the drug molecule. So, this oxygen having the capacity to take 2 electrons. See, 1 electron, these are it. 7 electrons, 7 electrons. So, one electron taken by this oxygen, another electron taken by another oxygen. See, 1 electron taken by this oxygen, another electron is taken by another oxygen. So, oxygen O2 molecule is deficient of 2 electrons, deficiency of 2 electrons. Hence, electron deficient. So, it need to take electron, always trying to take electrons from the drug molecule containing susceptible functional group, not all the drug molecules. The drug molecules containing the susceptible functional groups. So now, in order to happening of oxidation, when the oxidation will happen means oxidation is catalyzed by, in order to if an oxidation need to be done, it is catalyzed by 3 agents. One is oxygen should be needed, another one is metal, another one is light. What are the oxidation initiators? Chain initiators. We can call it as a chain initiators. Oxidation initiator. Initiator should be oxygen, O2. O2 is electron deficient. It takes electron directly from the drug molecule containing the susceptible functional group. Next one is metals. Next one is light. See, now we can discuss about the chain initiator, chain propagation, chain termination. In the chain initiation, the chain is initiated. See, always the chain is initiated by 3 catalysts. One is oxygen. Oxygen is electron deficient. It will take electron from, see, O2, take an electron from the drug. This is R nothing but drug. R nothing but drug molecule. It will take electron from this and makes this drug molecule to form free radical. See, free radicals are formed. Drug free radical is formed. If the oxidation is done by only, if the oxidation is happened by the oxygen molecule, we can call as auto-oxidation. We can call as auto-oxidation or rancidity. All the fat, all the oils which are using for cooking purpose, all the oils contain double bonds. The double bonds undergo auto-oxidation or rancidity. Very, very important term. Auto-oxidation or rancidity. So leads to the formation of free radicals. See, this is drug free radical, formation of drug free radical and this one. So in order to stop this reaction, means oxidation catalyzed by the oxygen, electron deficient oxygen, I need to stop this reaction. So what kind of agent I need to add in the parental formulation in order to stop the drugs, this drug solution, this drug oxidation. See, this is a container, this is a drug solution, This container, empty space containing oxygen, here empty space containing oxygen. Whenever this oxygen is there, here the drug molecule is there. This oxygen will attack on this drug molecule and leads to the happening of auto-oxidation or rancidity. Then how can I prevent the oxidation happened by this oxygen molecule? Oxidation done by this oxygen molecule present in the empty space of the container, by adding the antioxidants. We must and should the antioxidant whatever we have added, that will inhibit, means they will take this oxygen. Antioxidant, they take this oxygen. Whatever the environmental oxygen is there, they will take. That's all. Antioxidant, nothing but that one. Oxidation done by oxygen you can call it auto-oxidation, that is prevented or inhibited by antioxidant. See, mechanism of antioxidant to chain terminators and chelating agents, very, very important. Next one is metals. Chain initiated by oxygen completed. Another one is metal catalyzed. Another one is light. Metal. See, metal. See, now the metal is there. This metal take an electron. See, aromatic. A are nothing but aromatic, and oxygen that containing oxygen nothing but susceptible function group. Then this metal take an electron from this. See, two electrons are there. When I will take one electron from this, then 3 positive charge, 1 negative charge. When we add 1 negative charge to this, then +2, Fe +2. Then 1 electron. See, among 2 electrons, 1 electron is remained on the oxygen. We can call it chain initiated by metal. Chain initiated means oxidation catalyzed by metal. Oxidation catalyzed by oxygen auto-oxidation. Oxidation catalyzed by metal. So how can I prevent the oxidation catalyzed by the metal? Means by adding the chelating agent. Whatever the chelating agent that is we have added, that will trap. See, oxygen scavenger, nothing but antioxidant. We have discussed the examples. Those will take the oxygen. So what kind of agent take this iron means chelating agents. When we add chelating agent to this system, this chelating agent trap the chelating agent. See, this is a chelating agent, trap the iron molecule like this. We can call it chelating agents. So from where the metals are coming? See, the glass system, the metal, the container is made up of metal. When the leaching of metal into the solution, this whatever the released metal that catalyze the drug molecule oxidation. See, the oxygen present in the environment that will catalyze the oxidation. The released metal from the container, it will also make oxidation to the drug molecule, that can be prevented by adding the chelating agent. So see, if this is an aromatic drug, when the light is present, then light having specific wavelength, then this drug molecule get formation of free radical. The drug molecule will form free radicals. 2 free radicals will form due to the presence of light. So how can I prevent? So how can I prevent the oxidation? Oxidation means free radical formation. Free radical formation by light means just storing. We cannot see any agent that will not that will not take any light. Means even though it is taking light, too much light will come from the environment. Light will come from the environment. So how can I prevent? How can I prevent the oxidation catalyzed by the light? Means just ambered colored glass. Ambered colored glass. When we will use ambered color glass, so the drug solution we can store it in ambered color glass. Then that ambered colored glass prevent the entry of light from the outside into the solution. From the outside into the solution can be prevented by ambered colored glass. Say antioxidant, chelating agent, store the drug in ambered colored glass. Next, chain propagation. Chain propagation means already formed peroxide anion that will take an electron from the another drug molecule, leads to the formation of another free radical. Always there is a formation of drug molecule free radical. Drug free radicals are formed in chain propagation. Chain propagation means chain is always going. Chain termination. See, when the chain will be get terminated means, so this free radical and another free radical. See, this free radical and this free radical will combine and leads to formation of chain terminated. Here the chain get terminated. See, one electron. When the two electrons get paired, leads to formation of one bond. Thereby chain get terminated. So how can I prevent? So chain propagation and chain termination. So how can I prevent the chain termination? Means chain termination can be prevented. So the chain termination can be, or chain terminators we can use. Chain termination can be prevented by adding. Chain termination can be prevented by adding chain terminators. See, chain termination. See, chain terminators, what will do means, they just combine with whatever the free radicals are formed. Whatever the free radicals are, drug free radicals are formed, and the chain terminators having one electron, then there is a combining of one electron, this to this, leads to the formation of one bond. Leads to the chain get terminated. The chain will get terminated. This is about antioxidants, chain terminators. Say antioxidant act on oxidation catalyzed by oxygen. Chelating agent, metal catalyzed oxidation. Light catalyzed oxidation should be stored in amber color glass. Next, chain terminators act in the chain termination. Chain terminators act in the chain termination step. Chain terminators act in chain termination step.